Okay, so this is the class webpage. If you have any issues accessing this, just send me an email, a.stoikov@gavilan.edu. So this is the second C++ programming class. I hope you took 45 already, or you wouldn't be here most likely. This is going to be the class webpage. Everything that you need will be posted here. Everything that you turn in will be submitted through this webpage. So first thing is I have like a little welcome message, and we're going to go through that real quick. So my name, Alex Stoikov. This is 16 weeks long. Due dates, usually try to turn in things before the end of the week. So if I sign it this week, try to turn in by the end of this week. That way you understand what we're talking about when we get to next week. If you can't turn it in by the end of this week, don't worry about it. I don't like taking points off for things being late. So as long as you turn it in before the end of the semester, I'll likely grade it for full credit. If you want to resubmit something, you can. If you turn in an assignment and it doesn't get full credit, I'll leave you feedback. You're welcome to fix it and resubmit it for full credit. And that's why you want to turn in things early, so that you can take advantage of this resubmit thing that I offer you. If there's any quizzes, I've set them up to unlimited attempts. That way you can, if you don't like your grade, take the quiz again. One important thing about your grades, if you go to your grade book, student view, alright, you go to grades, and you're going to see there's this little checkbox enabled by default. Alright, that's just because Canvas sucks and they can't even get their gradebook right. So what this checkbox will do is it will mislead you about your grades. There was a few students in the summer classes that were thinking that, oh, I'm getting an A in the class, and they ended up with a C, alright, because of this gradebook feature. Alright, so let's say we have 100 assignments, you turned in 10 of them, and they each got 100%. The gradebook will make you think that you have an A in the class, because it will calculate the grades based on what you turned in only. I can't turn this off, I can't disable it, and it's on automatically for you. Right? So the misleading feature is on automatic. You need to turn it off in order to see your true grade. Okay? That's one important thing. Other thing that sucks about Canvas is if when you're turning in assignments, if you, let's say you have an assignment that has 2 files in it, you were working on one of them, you turned it in, you hit the submit button, then you went home and you decided to do the other one and you turned that one in. As soon as you turn in the second one, you will no longer be able to see your first submission. There's no way, I mean, you can resubmit both files at the same time, but as soon as you submit one file after the first submission, you no longer see your first submission. Alright? So I've complained at length about it and told everyone that needs to know about it, and I don't think they're going to do anything about it. Okay? But I'm telling you so you know. Okay? So if you submit multiple work, your old work, everything previous after the last, it will be hidden from you by default. I can see it, you can't see it. Don't ask why. Alright? Well, it's because of Canvas. Alright, so that's the welcome message, the important stuff. If you need help, send me an email. I'll get back to you within 24 hours on weekdays, 48 hours on weekends, usually faster. Okay, that's the max. And yeah, if you don't hear back from me within that time, send me another email. Okay, in your emails include CSIS46 so that I know which class you're from and maybe the assignment number that you're asking about. So yeah, that's as far as the little welcome message I got. And then there's a syllabus, so let's look at that real quick. And on the syllabus, you're going to see that there are some textbooks. Alright, so this is the official textbook. I will use some PowerPoints from it, but you don't really need to have this book. Okay, in my opinion, where did I pick this book? This is the book that USC uses. I looked at the book that Stanford uses, that Berkeley uses. I looked at like all the best schools and all over the place, what textbooks they used. And a lot of the textbooks are kind of like overcomplicating this unnecessarily, okay, in my opinion. But we need a good modern textbook on the syllabus, well, even though this one's like 15 years old, all right? This is what USC, one of the top computer science schools, is using, so I picked it for this class's official textbook, which is not required, okay? The other books that I'm going to be using and that I actually recommend over this one is these two. Okay, one is the data structures and algorithms in Java. So if you're taking the Java data structures class, there's this C++2 and there's also Java 2, right? Java 2 uses this textbook, right? Java 2 is also data structures, but with Java, this is data structures with C++. Most schools, like for example, Hartnell College only does data structures with C++. So if you want to do data structures with Java, you can't. And MPC only does data structures with Java. If you want to do a C++ data structures, you can't. We offer best of both worlds, or I offer best of both worlds. Okay, so these two I like better. Okay, and look for them online. You'll be able to find them online. Okay, so just try to find these books online. Of course, I mean purchase them, right? Oh no.
Oh yeah.
Okay, so I mean nice to see you.
Oh, you missed me.
That's what I meant. Okay, so these are the books, right, that I would recommend for you to understand the fundamentals of data structures. Okay, this one here on the right is this guy LaFour. He did one with C++. This is the earlier edition, and then there's this one, the data structures, the later edition. So this one's got more things in it, but it's applicable to Java. And by the way, Java and C++ are very, very close to each other. Okay, that's the reason why I'm using this textbook in the C++ class. Anyway, so these are the books that, especially the ones on the bottom, I recommend that you get. And anything else, any material that you need, I'll post. So you're not really required to get any of these, but it'll help if you get the LaFour data structures. All right, so that's that, and you can read the rest on your own, and let me know if you have any questions. Okay, so that's that. All right, so what I'm going to be using for this class, if you took CSIS45 with me, we used code blocks. You can use code blocks here too, but I would recommend that you use CLion. Okay, so CLion, you can just go Google, what is it? JetBrains student, right? If you just Google this thing, it says free for students, blah, blah, blah. Click this, click on apply now, right? And you're a student, put your name, your email address, your gavilan.edu email address, and these guys will send you a free license for a whole year, okay, for all their products, which is like $1,000 worth of products, which is a good deal. It's like if Photoshop or whatever, Adobe decided to say, hey, while you're in school, we're going to give you all our software free, which they don't, but they should, okay?
Yeah.
So yeah, JetBrains does that for you. So and the good thing about using their products is that since they're paid for things, you know, the CLion, I think it's like $200, maybe even $300. You get to ask for customer support. So if it doesn't work on your computer, send them an email. Tell them, hey, it doesn't work on my computer. I don't know what's wrong with it. And they'll help you, okay? You can also ask me for help, but now you have somebody who's getting paid to help you, okay? I wish Canvas was like that. Then it would be a real actual benefit to it, okay? So that's that, all right? And in order for you to set this thing up, let me go to week 1. So by the way, the class is broken into 16 weeks. When you go to the home page, you can go through these different weeks. Once you're in one of the weeks, you can go next, 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 and it will move through the different weeks. All right? And that's basically it. So, all right. So in there, I have a couple of links, MinGW and CLion on Windows. So in order for you to use CLion on Windows, you need to install a compiler. The compiler is called MinGW. And I think in here I have all the instructions that you need to install this thing and get it going. All right. Yeah. So if you have CLion installed without a compiler, it will give you some kind of a error message like this. You can't run the program without a compiler, basically. So what you got to do is you Google MINGW, then you click download, you install the thing, right? And then it will look like, when it's done installing, you open up the program. It will look like this, right? And you want to click the base and the MinGW32 disk, so basically this one and this one, I drew some errors in there, mark for installation, both of them, and then after that you click installation, apply changes, and it will download all the different things it needs and install the compiler on your computer. When it's done, it will look like this, right? And then you got to configure CLion. So you go to the file settings, and then you pick build execution deployment toolchains, and then in here you browse to the folder where MinGW is installed, which is usually just the C drive, right? C/MinGW, and that's it. If everything is good, you'll put a little check boxes in there. It's all good. Then OK it, and it'll take a little while to reload things, and then you can just build all and build the file name or the project name. This is project ABC. You click on build all, build ABC, and then it runs the program. Okay? So that's CLion. That's how to install the thing on Windows. And if you're on a Mac, it's a little easier, right? Still, you're gonna have to get your license and all that stuff, register the thing. To install the compiler on the Mac, you open a terminal and you copy paste this stuff, and you're done. Okay, and then I think it will automatically recognize whatever it needs, and that's it. Okay, so that's as far as CLion is concerned. And again, you're welcome to use code blocks, but I'm not going to be able to help you with code blocks if things go wrong. Okay, so make sure you use CLion.
Making our lives hard, huh?
What's that?
Making our lives hard.
Make your lives hard?
Yeah, you're making our lives hard.
No, I'm making your life easier. That way you can ask the support from JetBrains if you get stuck. I'm making my life easier. That's what I'm doing.
Okay.
Yeah. Okay. So, all right, drag and drop files into CLion. I'll let you read that stuff. All right. So submitting an assignment. Well, most of the assignments in this class are listed. P1, P2, P3. That's the naming convention I use. Have assignments link here. You can click on that, or you can go through the different weeks. That's what I would recommend. Right. So these are all the different assignments. They almost don't look published, but whatever. No, that's right. Okay. So yeah, all the assignments and the quizzes. So let me click on one of them. I don't have any assignments for this week, I think. Oh, nice. But next week we start with header files and stuff like that. Okay. So yeah, this is an assignment. You click it, and yeah, please complete the 2 assignments at the bottom of the PDF. You can include the PDF. Click submit assignment. Then you choose your file. You're going to be submitting the CPP files, right? And submit assignment, and then you're done. Okay. If you have any questions on that, let me know. Leave. So let's have a look at what I have for week 1. Looked at the syllabus. All right. So some review of C++, the first one, CSIS45. Some of the things you should know. Can you see this all the way in the back? Okay. Want me to turn off the light? You good? All right. So, pointers. Okay, so we're going to be using a whole lot of pointers in the data structures in C++. So, if you need to understand pointers better, I have this excellent video here from my old professor from USC, his name is Mark Redekop. Okay, he's really good. So if you're lost at pointers, if you don't understand the pointers, when you open up this thing, there's a link in there, and you can click it and watch the videos. They're about an hour long total, right? Excellent explanation on pointers. Okay, so what are pointers? Well, every variable, let's say for example we have a variable a something, right? This is the variable. The variable name refers to some place in memory. Okay, what is that place in memory? Well, that's the memory address. Okay, so if this is my variable a and I do cout %a, that will show me some number like 0x7ff blah 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 afc, right? That is the memory address of where a is, right? That's the place in memory. Okay, I can declare a pointer by just putting an asterisk in front of the variable name when I'm declaring it. Okay, so now this variable name, or a, the big A, is going to be a pointer. Okay, so what a pointer is, it's a special variable which is equal to the memory address of another variable. That's it. Okay, so in other words, we do something like this. So I declared a to be a pointer, and here I'm saying a is equal to %a. Right? So a is equal to the memory address of a, or now a points to little a. Big A points to little a. Okay? So using big A, I can pull the value of little a, right? So if now that I have pointed big A to little a, if I say cout *a, I can see the value that is stored into my a variable originally. Okay? So these are just the basics of pointers. Okay, so how you point one variable to another variable. What we're going to be using pointers for is we're going to be creating entire structures, and we're going to say, all right, this structure is pointing to this next structure, and then the next structure points to another structure, and we'll call that thing a linked list. Okay, that's coming up. So you're going to need to know pointers. Another reason you're going to need to know pointers is because of arrays. Right, so we're going to use arrays in here, and the way we're going to use, we're not going to use the regular arrays that we're used to in 45. We're going to be doing dynamic arrays. So the arrays that we've done in CSIS 45, basically we give them a fixed size from the beginning. Okay, but you cannot resize them when the program is running. Not at least in using the techniques that we're going to require for this class. So in this class, we're going to need to basically have a pointer to an array object, and then when we create our program for the first time, we're going to determine what the size of this array is going to be. Okay, but there's no other way to do it without pointers in C++. Okay, and one of my least favorite things about C++ is, it gets confusing with the pointer business. Okay, you have a single pointer, you have a double pointer, you have a left pointer, you have a right pointer. They came up with like 15 different pointer types just to make it fun. Okay, and then some other languages after that, like Java, said, you know what, just get rid of pointers altogether. So you don't really need them, but this is one of the low-level features of C++. It allows you to go deep at the hardware level and move things around memory and then tell it specific things. Okay. So pointer to pointer, yeah, you can have one pointer point to another pointer, right? So it's like a double pointer, right? If you have, this is my variable and this is my pointer points to variable, my pointer to pointer, the other pointer is going to point to another pointer. Okay, so it gets confusing, but don't worry about it. We're not going to use double pointers at all. I'll spare you. Okay, and there's some illustration here. If what I just said doesn't make sense, right? So look, we have a variable a, we have asterisk c, and double asterisk d, right? Asterisk c is my single pointer, asterisk d is my double pointer, right? Here I'm saying c is equal to %a, so c points to a, and then I'm saying d is equal to %c, so d points to c. So in here on this side, right? This is my variable a. Let's say this thing has, if I say %a, it's going to show me the memory address. So the memory address of A is 82C, right? Now this is my next variable, which is a pointer, right? The next variable also has its own memory address, right? And usually things are sequentially numbered in memory, right? So if this one is the 18, this one is going to be the 20, then the next one is going to be the 22C, right? So the numbers are after each other. Anyway, so when I say this here, when I say C is equal to ampersand A, I'm actually telling it, okay, the content of this variable C here is just the memory address of this other variable A, right? So just like this. So this points to this memory address. And then when I say D is equal to ampersand C, on this line, I'm basically telling it, okay, this variable D here, content of this memory address is just this other memory address. Okay, so what's the point of this? Well, this is what we refer to by D. This is what we refer to by C, but we also can refer to this value here as asterisk D. And this one here is what we refer to as A, but we can also see this value or refer to this value using asterisk C, or another way to refer to this is using asterisk asterisk D. What are these double pointers used for? 2D arrays, right? If you have a 1D array, one set of brackets, it's a single pointer. If you have a 2D array, two square brackets, it's a double pointer. Again, don't worry, I don't think pointers are that important in terms of the context of data structures. They're just a way to get things done. And since some of the other languages don't even use pointers, I'm not going to focus on pointers that much. Okay? But you need to know. Alright, some other things you need to know. Functions, right? It's how we group and reuse our code. Alright? We've done lots of functions in CSIS45. Right? Probably at least 20 assignments worth of them. Okay? So you need to know functions. How you do the prototypes, how you do the definitions. Okay? What we're going to be doing in this class is we're going to be putting all this stuff together into another thing called a class. Okay? And that's why I would recommend the order of things to be actually, if you could afford the time, do the 45 plus first. Actually, do the 42 first, then you do the 45, then you do the 24, which is Java, and Java is pure object-oriented programming. Then you do this one. But don't worry, you can go from 45 to 46. I'll cover everything you need. Okay? So you're going to learn about a whole lot about object-oriented programming, and we're going to use objects throughout the whole semester. Anyway, so functions, function prototypes is basically where you define what the name for the function is going to be. You have your function call, which is where you execute the function, do whatever's inside of the function, and the definition, which is what's inside of the function. Okay? What's an argument? What's a parameter? Remember what's the difference? Anyone? What's an argument? Excellent. So the value that you put into the function, right? So this is my function called a parameter, which has an int parameter variable here. So that's what a parameter is, right? It's the variable between the parentheses. And then the argument is the actual value that we pass into the function. So as soon as I call this function right here, a parameter parentheses 10, this variable, parameter variable, equals 10. And then we do something with it, right? Maybe you can just show it or do some kind of math with it, whatever. Okay, so parameter, argument, function call. All right, these things you need to know. The local and global variables, scope. All right, what was the local, what was global? What's local? It's okay, so local is a variable which is inside of a function, and you can only use that variable inside of the function. Right? So for example, right here, this function, what are the local variables here? Sum, and actually these are also local. The parameter variables, num1, num2, they're also local. Right? In this case, a parameter, this parameter variable is local to this function. So it can only be used inside of this function. Okay? A global variable will be a variable that is somewhere outside, like right here. See, a global variable is declared before and outside of all these other functions, which means that all the functions have access to it. I can go in there and I can, I can change the value of this variable from inside any of the other functions, which is why using global variables is not a good idea, because any function can go and mess the data of some other function. So you want to kind of bundle the data together in only relevant, pieces of code. Okay, so you don't want somebody working on one part of the project to be messing up with your part of the project, which is why we stay away from global variables as much as possible. Okay, so global variable, local variable, there's a bunch of comments in there. Most of this stuff is from the C++ class. It is from the C++ class. Okay, all right, pass by value, pass by reference, pass by pointer. In this class you're going to see some of this, not a whole lot. Okay, the difference between pass by reference or pass by pointer. Okay, so first of all, I have a couple of functions here, right? Pass by value, int param, right? This is my pass by value. Okay, so what I'm doing in the pass by value here in line 38 is I'm just saying, okay, well, this param variable is equal to 0. Okay, so I'm passing the value a in here, and I'm saying param is equal to 0. So what's going to be the value of a after? You want to say 0. It will be a 101, right? So a is equal to 101 initially. I'm doing a pass by value, which is just you have a regular variable in between the parentheses, and then I'm saying, okay, well, this variable here is equal to 0. Changing the content of this variable here does not affect my a from the main. Okay, because a is local to the main, param is local to pass by value. Changing one doesn't change the other. Make sense? That's what we did for most of the C++ class. But we also did some of this stuff. We might have done it with pass by pointer or pass by pointer or pass by reference. So let's look at the pass by reference or pass by pointer first. So what is pass by pointer? Oh, same thing as pass by value, except we added a little asterisk in front of the variable. So now it's a pointer. Okay? Then inside of the function, what I'm going to do is I'm going to say, okay, oh, and by the way, notice how we're calling it. When I say pass by pointer, I'm doing %a. So I'm actually sending, I'm not passing the value of a like I did here. In here, I'm actually passing the value 101. So whether I do pass by value a or pass by value 101, I'm still sending over the 101 into the function, not a. In here, pass by pointer with the %a, I'm sending the memory address of a into it. So this variable param actually refers to a. So if I do asterisk param is equal to 0, this changes my variable a from 101 to 0. Right? So initially here it would show you a is equal to 101. This one here is going to show you a is equal to 0 because we changed it right here. Okay. Input pointer. You can do the same thing with the cin, basically, right? Same thing that you did on top, but this time with the cin from the user. Same thing. The one that's different is pass by reference. Look at the pass by reference. It's similar to the pass by pointer, except instead of an asterisk, we have an %. Okay? So pass by reference and pass by pointer allow you both to do the same thing, which is by changing param here, I am going to change the variable a here. Okay? So the only thing that's different is the syntax. One uses an asterisk, the other one uses an %. The other one uses an asterisk inside when you want to do the change. The other one doesn't. The pass by reference does not use this. So what is the difference between pass by pointer and pass by reference? Well, with pass by pointer, this variable asterisk param or the pointer variable can be repointed to another variable. So inside the function, I can go and say, well, now point it to some other one, okay, to some other function. And The other one, pass by reference, can't. With the pass by reference, we're permanently connected to the A. So the variable at param or ampersand param is permanently connected with the A. We cannot repoint it anywhere else. Okay? But so two ways to do the same thing. Why? Because it's C++. Like one way is not enough. They want like a million different ways. Okay? Questions? All right, we're still reviewing. You should have learned this, right? Okay, so arrays. This is the syntax for creating an array of 5 things, right? And arrays are just basically a fixed list of numbers. You make it a 5 and it stays as 5. You make it a 6, it stays at 6. You cannot expand an array, you cannot shrink an array. Even though C++ will kind of allow you to do things, you can't, right? So, just so you know. So you can either give it the number and it will create an array of this size, or you can leave the square brackets empty and then you can do equals, and these here are curly brackets, right? Curly bracket, and based on these, however many numbers we have in between the curly brackets, that's how many array elements we're going to have, right? The array elements, so let's say this is an example of we have an array of 3 things. What are going to be the values of the elements initially? Do you remember your C++? Garbage. Garbage, right? It could be zeros, but don't count on it. It could be 0, it could be 1,000,001, it could be -953, whatever. Pick a random garbage number, okay? Unlike Java, which initializes things to 0 automatically for you, C++ is not very nice. Okay, so what we're doing here is I'm initializing the different elements. So this is an array of 3 elements, right? Size is 3. The first element has an index 0, second element has an index 1, third element has an index 2. Elements start at 0, they go to 1 less than however many things you have. Okay? And some examples of showing an array, entering information into an array, and then showing the array again. Okay? Strings. We're not going to do a whole lot of strings. Maybe like one assignment with strings. When we do stacks, I think. Stacks and queues. I think stacks. Yeah. Anyway, a string is basically a character array. So this is my string name is equal to Alex, and there's this char name 25, and so the string is basically a character array that ends with this \0. Okay? So this is the null terminating character. This is how C++ knows we got to the end of the string. Okay? So whether you do a character array like this or a string, it's pretty much the same thing. All right? And then at the end, it shows you the null. All right, that's the last one. Arrays and functions. You can send your arrays into functions like so. This is something we're going to use all the time in this class, so get comfortable with it, or reacquaint yourself with this if you forgot it. All right? So we can pass an array into a function. You're just saying and square brackets, and then it's a good idea to send the size of the array also, because you cannot, because of the issues with pointers, you cannot figure out the size of the array into the function once you send it. You can figure it out wherever you created it. So I'm creating my array, and here I can figure out the size of the array in the main. But if I'm passing the array, and this is how I'm passing array into a function, I'm not putting square brackets, even though this is an array, I'm putting just the name. Okay, this will pass the whole array into the function. Okay, when I pass the array into the function, I'm actually passing it as a pointer, which means that if I start doing some changes to this array n inside of this function, like I'm doing in this one in change array, what will happen is I'm going to update the value of array n in here. Okay, so we're always, whenever you're passing an array, the whole array into a function, you're passing it as a pointer or a reference, whatever you want to think of. Okay, Any questions? All right. One more thing that you learned
Oh god.
is the bubble sort, which is the easiest of the sorts. There's actually a lot more other sorts, and I'll do more than the ones in this class. And if you take the Java one, right? In the Java, I do probably like three more advanced sorts.
So,
Yeah, there's a quick sort, shell sort, some other ones too.
Insert.
And you gotta learn. Yeah, there's insert, there's select, there's merge sort. So you'll learn a few of these in the class. Okay, so what was the bubble sort? Well, you can Google it and look at the Wikipedia page and look at how the numbers move. If you don't remember, anyone not remember bubble sort?
One thing that went down to smallest things.
Yeah, let's Google it. Let's Google it.
I can't Google it.
I'll Google it for you.
Yeah, I don't know why it doesn't like me.
Oh,
Yeah.
it's not working with you too?
Yeah, it won't let me get to the authorization page. And when I do get there, it like says, there's a possibility you're getting hacked, and I say, yes, I know, just let me get to the Wi-Fi, please.
I can't log in my phone right now.
All right, so look at this thing here. This is your bubble sort illustration, basically. All right, you have a list of numbers, and the algorithm is this. You go through this list of numbers, two at a time, compare the left to the right. If the left is bigger, you swap their values. Then you move down. Is the left bigger than the right? No. Move one down. Is the left bigger than the right? Yes. Swap their values. All right, and you keep doing that. So the first time you do this by passing through all these numbers, the biggest number is going to move all the way to the right, okay, or bubbles up to the top. That's why it's called the bubble sort. All right. Second time you go through it, it will do it for the other number. Where's the other picture? Here's the other picture. All right. So if you have a bunch of data scattered all over the place, right? You have a bunch of numbers, a list of 100 random numbers. It starts sorting them, highest to lowest in this order, right? That's your bubble sort. Okay. If we go back up to that original one, all right. Now it's done with the first time. Now it's going the second pass, and it's going to move the second biggest number to the second to last. Okay. So that is basically the idea, and this is the code for it, right? So we have a bunch of elements, an array of different numbers. We have two loops. All right. This one here compares two numbers that are next to each other, and if the left is bigger, if left is bigger than the right, swap their values. Okay. So we go through all the numbers one time. This is the inner loop, right? And then to repeat this loop as many times as their numbers, we do this loop, right? This sorting algorithm here is a little bit, it's an improved version of the one that you learned in the C++1 class, because what I do, one thing here is I'm also reducing how many times this loop happens. Okay, so basically when you look at with this page, at this point when I have these first four numbers lined up, I don't need to go and do it all again for all these other numbers. So basically the outer loop can stop earlier. Okay, so that's the bubble sort here, right? And nothing else, nothing fancy. Okay, but these are basically the contents of 45. You should be comfortable with all this, especially with pointers and arrays and functions, which is like everything. Okay, so yeah, you should be very comfortable with everything we did. But don't worry, I'll go through these things again. And yeah, if you're not comfortable with pointers, look at Redicop's lectures. Okay? Any questions? I don't speak that weird language.
Oh, wow.
Sorry. Okay, so next week we're going to talk about the different types of data structures. I guess I should mention them. today, so you have an idea. Okay. So, all right. So some of the data structures that we're going to cover in this class are bag, stack, queue, linked list. We're going to do circular lists, double linked, double-ended lists. We're going to do trees, hashes, heaps, graphs, I think. Okay. And in there also I'm going to throw some operator overloading, and if time permits, maybe something else that I might add this semester. Okay. So what are data structures? Just so you might wonder. Just the ways for us to represent real world data and interact with it. Like you're going to have some kind of a real world scenario. Like, okay, we have a line of people, right? How's the line of people work? Well, you get on the line, there's a bunch of people in front of you, the first person at the front is the first one to leave the line, right? So you come at the end and you leave at the front. Okay, what is this called? Well, that's a queue, right? So that is an example of an abstract data type. We know the idea of how something is going to work, but how we're going to make a program out of it, well, that will be the data structure. So the data structure is the how, the implementation of an abstract data type. Another example of an abstract data type, and that's the one that we're going to start with, actually in week 4 it appears, okay, is a bag. What's a bag? It's a collection of items, right? They don't have to be in any particular order. There's a bunch of them in there. You can go through the bag and look at the different items. You can maybe figure out how many items there are. You might be able to get an item and remove it from the bag, and you can add an item to the bag. That's about it, right? So very basic, collection of data things, right? You can have a bag of names, bag of grocery products. Real world example of a bag is shopping cart. Huh? A bag of what? Okay, yeah. Thanks. Yeah. So, yeah. And basically that's the idea. We're going to have some real world, situation, and for different situations, different data types make sense, right? Sometimes maybe you want to go through a million things and go to a specific one and look at that one. Well, that would be a good idea to use maybe a array or a dictionary, okay? These hashes that we're going to talk about. Or maybe you have, a stack, and that stack is used in memory. Okay, when you call functions, they get pushed on a stack, and then they get pulled from that stack or popped from that stack. What's an example of a real world stack? Stack of plates, right? You're in the kitchen, you have a stack of plates, right? The last one goes on top, and then how are you going to wash these? You can't start pulling. Well, you could start pulling from the bottom, but you might break a bunch of them. So what do? You start from the top. Wash the top one, put it on the side. So there's 2 possible operations that could be done on the stack. You can push on the stack, put the plates on top, or you can pull from the stack, or pop from the stack, which is take the plates off the stack. Okay? So there's a whole bunch of these other ones, like there's a linked list. Linked list offers some advantages over arrays. First of all, arrays, they offer a quick search. So going through, well, not a quick search, but they offer the ability to jump to a specific index. Let's say you have an array of 500,000 things. You want to go to 499,000th one, right? You can just type in the index and you jump straight to that one. Okay, but let's say you wanted to insert something all the way. Let's say it's an ordered array, and you're trying to insert all the way at the beginning of that array of 500,000 things. What you have to do is, in order for you to kind of make it resize and do things, you're gonna have to shift all elements to the right. So you're gonna have to move all 500,000 things to the right by 1 slot, just so that you can insert one in the beginning. All right, so it's a very slow insert. And if you wanted to delete something, let's say you want to delete the first one in the array, you would delete the first one, and then you're going to have to shift all the other 500,000 things to the left, or 499.999, right? You're gonna have to move them all one slot to the left. So insertion and deletion, if we're trying to kind of resize the array or do that kind of thing, is very slow as far as arrays are concerned. But if we can create our own structure where one thing links to another thing and then the next thing links to another thing, and you can just kind of reconnect the links, then using a linked list, you can do it with only just 3 moves, right? Reconnect a couple of links in this linked list and you're done inserting. Reconnect a couple of links and you're done deleting, right? So for different purposes, for different data, it makes sense for it to be implemented with a different data structure, right? And for example, trees. If you have like some kind of an organizational chart, right? It makes sense to have a tree. And then trees become very useful when we're trying to find the smallest and the largest, okay? Graph is a little bit more advanced topic, but we'll cover, we'll get a general overview of it. Graph data structures are useful for when you're trying to figure out things on a map, right? You have a bunch of cities, which way traveling from which city to which city takes, or which path takes the least amount of time. Okay, these graphs are actually used when we're talking about the internet. The internet has a whole bunch of routers. The routers collect information about how fast the different paths are and how do we solve these problems of figuring out the quickest path. Well, we could use a graph. Okay, so different real world problems and real world data are more suited for different types of data structures. Can we do it all with arrays? Maybe, but it's not the best idea. Okay? And efficiency and figuring out how quickly things run and how efficient our algorithms are is one topic that we're going to cover in this class. That's why we spend some time in this sorting and recursion business. And one of those, the reasons is to show you the efficiency of algorithms. That's going to be the big O notation. Right? How fast is the bubble sort compared to the insert sort, compared to the select sort? Why is it faster? This kind of analysis goes into the computer science field. And that's what we're going to do. Okay? So what do you have to do for this week? Read through these things, right? Look for the book that's on the syllabus, the LaFour one at least. Okay, both of them. There's one, the C++, and there's the Java one. Get both of them. And next week, I'm going to tell you a little something about header files. I'll tell you a little bit about them now. Header files are basically where we write our function prototypes. So normally in a typical C++ class, it gets really confusing because they focus on, like, you're going to have one project and you're going to break it down into like 15 little files, and there's going to be like 15 little header files, and then based on these 15 header files, you're going to have 15 little other CPP files that are connected with them, and then you're going to have a main, and then the main connects all of them, but then with this linking of multiple files, all kinds of stuff can go wrong, and it's a pain to debug. Okay? Well, I'm kind of taking the Java approach in this class, which is Java doesn't have header files. So I'm going to show you what header files are and how to use them and how to work with them so that you know how to use them, and I'm just not going to use them for the rest of the semester. No header files. Okay, so there'll be one assignment about header files, so you know, and then next week after that, we're going to talk about deleting and inserting from arrays, okay, which is important stuff, and I don't think I covered enough of it in the 45 class, but it will illustrate why it's slow, why this process of deleting and insertion is slow in arrays. Okay, we'll talk about array encapsulation, your first introduction to, this class's introduction to classes and objects, and then we'll move on from there. Okay, which is next week is then we introduce the chapter 1 or whatever, which is the bag. Okay, so I like how I have set up this class. I think you're gonna like it too. Data structures is supposed to be the most complicated programming class you take, but I think I make it easy. All right. So that's all I have for today. Thanks for coming. Hope to see you next time again. Maybe not you. But make sure that you log in to the class webpage at least once every week. Turn in the assignments that are given to you by the end of that week. Okay? Because it will get a little more time consuming and more difficult. Treat it like a math class. All right. Thanks for coming.